Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter hyperbolic functions, lecture number 8, in which I will solve some more problems on hyperbolic functions. Now we solve a problem. Problem is so that the sum of moduli of values of 1 plus I whole to the power 1 plus I, which are less than unity, is given by 1 by square root 2 e to the power 3 pi by 4 cosec hyperbolic pi. Now we solve this. Before solving this problem, I would like to give you some basic concept. Modulus of e to the power alpha plus I beta equal to e to the power alpha multiply e to the power I beta modulus. This is equal to modulus of e to the power alpha multiply e to the power I beta is cos beta plus I sin beta. Modulus of these two is modulus of e to the power alpha modulus of cos beta plus I sin beta. This is equal to e to the power alpha is non-negative. So modulus of this is e to the power alpha multiply modulus of this is cos square beta plus sin square beta square root, and this equal to e to the power alpha multiply this is 1 square root, means e to the power alpha multiply 1 equal to e to the power alpha. So modulus of e to the power alpha plus I beta is e to the power alpha. Since 1 plus I whole to the power 1 plus I equal to e to the power x, means 1 plus I capital log 1 plus I. Since a to the power x equal to e to the power x log a, here a is 1 plus I and x is 1 plus I. Let this is number 1. Since we know that capital log w equal to 2n pi I plus small log log w. Therefore capital log log 1 plus I equal to 2n pi I plus small log log 1 plus I, and this will be equal to 2n pi I plus value of this is half log alpha square plus beta square. Alpha is 1 and beta is 1. So this is 1 square plus 1 square plus I tan inverse beta, means 1 by alpha 1 by 1, and this will be equal to 2n pi I plus half log 2 plus I tan inverse 1 is pi by 4. This is equal to 2n pi plus pi by 4 I plus, this is log 2 to the power half, means square root 2. Let this is number 2. Therefore 1 plus I to the power 1 plus I equal to e to the power 1 plus I 2n pi plus pi by 4 I plus log square root 2. This is equal to, we firstly multiply this by 1 e to the power 2n pi plus pi by 4 I plus log square root 2. Now we multiply this bracket by I multiply I square means minus 1, 2n pi plus pi by 4 and here plus I log square root 2. This is equal to e to the power 2n pi plus pi by 4. Here I, here also we have I. So we take common I, log square root 2 I plus log square root 2 minus 2n pi plus pi by 4. Let this is one bracket and this is another bracket. Implies that modulus of 1 plus I to the power 1 plus I. In modulus, we have just seen that e to the power alpha plus I beta. This is beta. This part is beta and this part is alpha. Is e to the power alpha. So this is equal to e to the power log square root 2 minus 2n pi plus pi by 4. Since modulus of e to the power alpha plus I beta equal to e to the power alpha. So this is equal to e to the power log square root 2 multiply e to the power minus 2n pi plus pi by 4. This is equal to e to the power x log a, means a to the power x. Here e to the power x means 1 log a equal to a to the power x square root 2 to the power 1 multiply 1 by e to the power 2n pi plus pi by 4. Let this is number 3. Putting n equal to 0, 1, 2, dot, 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 dot. The right hand side of 3 will be square root 2 by n equal to 0. Here remains e to the power pi by 4, comma, square root 2 by e to the power, here n equal to 1, 2 pi means 8 pi plus pi, 9 pi by 4, comma, square root 2 by, here n equal to 2 means 4, 16 plus 1, 17, e to the power 17 pi by 4, comma, dot 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 dot. Let this is number 4. Since square root 2 second term, square root 2 by e to the power 9 pi by 4 by square root 2 e to the power pi by 4 is 1 by e to the power 2 pi. Similarly, third term by second term, square root 2 by e to the power 17 pi by 4 by square root 2 by e to the power 9 pi by 4 equal to 1 by e to the power 2 pi and dot 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 dot. Therefore, 4 is in GP, whose common ratio equal to 1 by e to the power 2 pi, and this is less than 1. Therefore, sum of all members of 4 will be, first term is square root 2 by e to the power pi by 4 by 1 minus 1 by e to the power 2 pi. Since if r is less than 1, then a plus ar square plus dot 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 equal to a by 1 minus r in GP. And this will be equal to square root 2 by e to the power pi by 4 multiply e to the power 2 pi, here e to the power 2 pi minus 1, and this will be equal to square root 2 multiply e to the power 2 pi minus pi by 4, and we divide this by e to the power pi, and e to the power 2 pi minus 1 by e to the power pi multiply e to the power pi. So this will be equal to square root 2 to e to the power 2 pi minus pi by 4 by e to the power pi minus e to the power minus pi. Let we divide this by 2 and multiply this by 2. So this will be equal to square root 2, here 2. So 1 by square root 2 e to the power, 2 pi minus pi is pi minus pi by 4, means 3 pi by 4 by, this is sine hyperbolic pi, and this is equal to e to the power 3 pi by 4 by square root 2 cosec hyperbolic pi, and proved. Now we solve the next problem. Next problem is prove that tan inverse under bracket cot theta multiply tan hyperbolic equal to 1 by 2i log base e sin theta plus I phi by sin theta minus I phi. Now we solve this. Solution. Since sin theta plus I phi equal to sin A plus B, sin A into cos B, cos I phi, plus cos A, cos theta into sin I phi, implies that sin theta plus I phi equal to sin theta multiply cos I phi, means cos hyperbolic phi, plus cos theta sin I phi, means I sin hyperbolic phi. We may write this as sin theta multiply cos hyperbolic phi plus I cos theta multiply sin hyperbolic phi, implies that log sin theta plus I phi equal to log sin theta multiply cos hyperbolic phi plus I cos theta multiply sin hyperbolic phi log alpha plus I beta. This is alpha and this is beta. We know that log alpha plus I beta equal to half log alpha square plus beta square plus I tan inverse beta by alpha. So we write this half log alpha square means sin square theta cos hyperbolic square phi plus beta square cos square theta sin hyperbolic square phi plus I tan inverse beta by alpha. Beta is cos theta sin hyperbolic phi by alpha is sin theta cos hyperbolic phi. This is equal to half log sin square theta cos hyperbolic square phi plus cos square theta sin hyperbolic square phi plus I tan inverse, this is cos by sin cot theta and tan hyperbolic phi. Let this is number 1. Replacing I by minus I, we get log sine theta minus I phi equal to half log sine square theta cos hyperbolic square phi plus cos square theta sine hyperbolic square phi minus I tan inverse cot theta tan hyperbolic phi. This is number 2. Subtracting 2 from 1, we get log sine theta plus I phi minus log sine theta minus I phi equal to, first term will be cancelled, only remains 2I tan inverse cot theta tan hyperbolic phi implies that log sine theta plus I phi by sine theta minus I phi equal to 2I tan inverse cot theta tan hyperbolic phi implies that tan inverse cot theta tan hyperbolic phi equal to 1 by 2I log sine theta plus I phi by sine theta minus I phi. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.